Okay, this is a screencast about absolute value equations and inequalities. So let's start with this one, and you probably know the answer to this one. You probably know that 2 is equal to 2, but the absolute value of negative 2 is also equal to 2. There's two solutions here. So what we have to do is basically split it up into two cases, a positive case and a negative case. So in the positive case, I usually write, instead of absolute value, I write parentheses, and x equals 2. That's the positive case. In the negative case, in front of the parentheses, I'll write a negative sign, and that's equal to 2. I'll just solve both sides. Well, this one's really already solved, x equals 2. On this side, you just divide by negative 1, moves the negative to the other side, and you have x equals negative 2. So we got both our answers algebraically. Now, let's get some graph paper here. If we were to graph that, and I understand that we are not to the point of graphing absolute values yet, but you should know that this one is not that hard. If we graph that as two basic equations there, so if we say y equals 2, like that's the right side, and then y equals absolute value of x. The y equals 2 is a horizontal line, looks kind of like that. The absolute value of x has a vertex at 0, 0, and it kind of goes up and to the right at a slope of 1, and then it looks like a V, absolute value. So that V in the value causes the graph here. Essentially, the graphs are always going to be kind of V-shaped. Sometimes they're kind of flipped around, but they're V-shaped. And you can see pretty easily that when x, the x-axis is here, and the x is 2, and x is negative 2, those two graphs cross. So they cross at 2 points. I just want you to see that there are two potential answers here. X equals negative 2, and x equals positive 2. So you should expect, typically, with absolute values, to have two solutions. That's what normally happens. So let's try another one here. See if we can solve this one. Let's put it in two cases. We'll take the positive case. 2x plus 1 is positive and equal to 5. And we'll take the negative case. Negative 2x plus 1 equals 5. And now you have a choice over here on the right. Well, let's just solve the left one first. You subtract 1, you get 2x equals 4. Divide by 2, you get x equals 2. And over here you have a choice. You either distribute the negative or you divide both sides by negative 1. I'm going to divide both sides by negative 1. I get 2x plus 1 equals negative 5. Subtract 1, 2x equals negative 6, and then divide by 2, x equals negative 3. So no surprise that we got two solutions. Notice they're not exactly opposites of each other. Sometimes students would just think, oh, well, 2 is a solution, so negative 2 must be. Now, and if we plug them back in, it's not a bad idea to plug them back in here. And if you do that, you notice 2 times negative 3 is negative 6, plus 1 is negative 5. The absolute value of negative 5 is 5, and 5 is equal to 5. So that value works. We could plug in 2 also. That's a little easier. 4 plus 1 is 5. That's 5. That works also. So good idea to check your work in this section. We'll see that come into play in a minute, maybe. Always isolate the absolute value first. And so you really want to kind of get that part, this part here, all alone. So get the other stuff to the other side. So let's move this 1 over first to the right by maybe subtracting. So we have 2 times absolute value of 3x minus 4 equals 10. Then we're going to divide by 2. We get absolute value of 3x minus 4 equals 5. We divide it by 2. Now you've isolated it, so now you split it up. Don't split it up to start with. You will get this problem wrong every time. So you want to isolate it first, and then you have 3x minus 4. That's the positive case, equal to 5. In the negative case, we have a negative in front. 3x minus 4 equals 5. Go ahead and solve those. You get 3x equals 9, so x equals 3. And I'm going to go ahead and distribute this time, just show you a different way. Negative 3x plus 16, if I distribute that negative, equals 5, so negative 3x. If you subtract 16, you get negative 11, and so you get x equals 11 thirds. A little harder to check that value, but you can check that value, you can check that value, and they both should work when you plug them in. That would be 11 minus 4 is 5, and this would be 9 minus 4 is, let's see, wait, sorry, let me plug that in. You get 11 thirds, so that'd be 11 minus 4 is 7. Did we make a mistake here? I did. So you will catch your mistakes. That's another benefit here of checking your work, is if you happen to make an arithmetic mistake, you'll catch that. And so this should have been positive 4 here when I distribute the negative. I wasn't multiplying by 4, I was just distributing a negative. So then we get negative 3x equals 1, so x equals negative 1/3. If we were to plug that in, negative 1/3 times 3 is negative 1, minus 4 is negative 5. The absolute value of negative 5 is 5, so that value does in fact work. So you can check them both and make sure they work, make sure you didn't make any silly mistakes, and you've got it. This one, again, more of the same. You just got to subtract. Here, we're going to solve it. So we get negative 3 times x plus 7 equals 3 now. 6 plus 9 is 15. Okay, divide by negative 3, you get absolute value of x plus 7 equals, divide by negative 3, you get negative 5. That looks a little funny. Some of you may have an idea what's going to happen here, even at this point in the problem. In fact, you might stop and know the answer to the problem right now. But if you don't, let's follow our pattern and see what happens here. So we get x plus 7, positive case, equals negative 5. That's our positive case. Our negative case would be the quantity, a negative quantity of x plus 7 equals negative 5. I want to solve this. I get x equals negative 12. I'm going to divide by negative, I get x plus 7 equals 5, so subtract 7, x equals negative 2. Something seemed a little funny there. So let's just make sure we're making no silly mistakes today. This is negative 5. And we subtract 7, we get negative 12. And so I've done the math correct, and I circle these answers, and we're on the next question, and I would get this problem wrong. And it largely came from this part right here, this step right here. You might have noticed something's a little off. And the reason I know it's wrong, what happens if I plug in my negative 2? Let's see what happens. I get the absolute value of negative 2 plus 7 equals negative 5. Well, I plug that in, I get 5 is equal to negative 5. Well, that's not exactly true. That side's 5, that side's negative 5. That doesn't work. Plug in negative 12. Negative 12 plus 7 is absolute value of negative 5, which is positive 5, which is not equal to negative 5. That answers out as well. So we get two solutions that are not really solutions, they're extraneous solutions. You might could have figured it out right here. And the reason I say that is because absolute value will always be positive. Right? We know this left side is always positive. Well, the right side is negative. How could those two sides be equal? They simply can't. And so we just say no solution. But it's very tempting because you'll get answers, but they're just not real answers. They're extraneous solutions. So we say our solution is really no solution there. What value makes this inequality true? So now we're dealing with inequalities, and you have to be careful with this. We don't want this less than sign. So anytime you see a less than sign, I know I'm spelling this wrong. I'm doing it on purpose for a memory trick. Less than, the less than symbol is an and. If you saw a greater symbol, I want you to think greater, greater. So that's when the absolute value is on the left. Less than is always an and greater greater than is always an or symbol. So this is really an and symbol here. So we say, okay, let's split it up. We say x is less than 3. Or we say negative x is less than 3. Well, that's part of my answer. This is an and, so I want an and symbol there. And I solve this, I get x, I get negative 3, and I flip the signs, put the direction, I get x greater than negative 3. To see what this looks like, it's a good idea to draw a number line. When you do that, you'll see that this part would be something like this, looks like this. Open circle goes left. This part is open circle goes to the right. And the and statement means I take the overlap of the two, and hopefully you see it. The overlap of both of those would be between negative 3 and 3 and everything in between. So that would be my graph. My final answer algebraically might be something like negative 3 less than x less than 3. Or I could say it this way. I could say a lower bound of negative 3, comma, upper bound of 3, then both parentheses. That's interval notation if I prefer that. There is a shortcut to this. So the shortcut is look at the original problem. Okay, absolute value of x less than 3. And you basically say, okay, I'm going to add something to this. I'm going to add something on this side. I'm going to put, if this is positive 3, I'm going to make it negative 3 over here. And I'm going to go ahead and erase those absolute value signs. And look how fast that shortcut was. I have my answer. X is in between negative 3 and 3. And so if you just add that on the other side and solve, that's a real quick shortcut. So if you see this one, well, we'll get there in a minute. This is a greater than problem. So let's set it equals 0 first. I mean, solve it for the absolute values on the left. Isolate it as much as you can. Get greater than or equal to positive 4 here. That looks okay. That's a positive number. Okay, so I'm going to split this up into two cases. I have x plus 1 over 2 greater than or equal to 4. And I have negative absolute value of x plus 1 all over 2 greater than or equal to 4. So this one you solve and multiply by 2, you get x plus 1 greater than or equal to 8. And x is greater than or equal to 7. Got it? Here, distribute the negative first probably, so you have x plus 1 over 2 less than or equal to negative 4. Had to flip the sign. Multiply by 2, you get x plus 1 less than or equal to negative 2. Subtract 1, you get x less than or equal to negative 3. And this is or, so these be connected by the word or here. So we're saying x is greater than or equal to 7 or x is less than 3. If we saw a number line of that, it might look something like this at 7 and at negative 3. And it might be like, let's see, less than that, so that way, and greater than this or equal to this, so there'll be a closed circle and going to the right. And there's your graph of that. Let's try one more. I want to make sure you're getting the shortcut. Shortcut's really handy. So on this one, I'm just going to put less than or equal to negative 6 on this side. And over here, I'm just going to erase the absolute value bars there, without erasing the 2, hopefully. So I'm going to add 2 to both sides. Oh, wait, all three sides. I get negative 4 less than or equal to 5x less than or equal to 8. Divide by 5, you get negative 4/5 less than or equal to x less than or equal to 8/5. And that is how you solve it. So the nice thing is if you use the shortcut, it's already in the right form. You don't have to really graph it to figure out what it looks like. You just kind of got it there. And so go ahead and do your homework. Look for shortcuts. The shortcut only works. Shortcut only works on AND statements. It does not work on OR statements. So only AND statements will the shortcut work. Enjoy.